the strategic defense philosophy of the Imperial Japanese Navy, IJN, and the Imperial Japanese Army, IJA, in the vast expanse of the Pacific during 1943 was fatally rooted in a doctrine of calculated predictability. Japanese military planners, facing the growing and undeniable industrial colossus of the United States, focused their desperate and dwindling resources on countering a threat they believed was structurally immutable. Their entire defensive strategy was predicated on the rigid classification of Allied air assets. They knew the speed of the F-6F Hellcat fighter, the payload of the SBD Dauntless dive bomber, and the range of the TBF Avenger torpedo bomber, and they built their defenses accordingly. The critical and ultimately fatal assumption was that Allied fighter aircraft, the very core of the carrier's defensive screen, were strictly limited to the air-to-air role. Japanese generals and naval strategists firmly believed they had mastered the physics and logistics of the Allied strike package. They calculated, based on their own technological experience and capacity for manufacturing, that any weapon capable of inflicting serious, precision damage upon fortified installations had to be carried by a heavy, slow-moving bomber. This reliance on the physical limitations of conventional ordnance created a clear, predictable window of vulnerability for Allied air operations. Their fast, nimble fighter screens posed a threat to air superiority, but they posed no existential threat to static ground assets or hardened bunkers. As a direct consequence of this rigid thinking, Japanese ground installations were systematically fortified to withstand the relatively slow, high-altitude attacks of conventional bombers, but the ground-level anti-aircraft defenses were dangerously inadequate against the kind of fast-moving, low-altitude approach that only a dedicated fighter could execute. This was the chasm in their defense matrix. This reliance on predictable strategy was further compounded by a pervasive Japanese philosophy of underestimation regarding their enemy's ability to innovate and adapt. They believed that the superior training and martial spirit of the Imperial fighter pilots, flying agile aircraft like the Zero, could maintain a qualitative edge against the supposedly crude American production. They dismissed the possibility that robust, carrier-based American fighters, built for durability and speed, could possess the necessary precision for close ground support roles. This rigid separation, fighters fight, bombers bomb, was more than a tactical classification. It was a deep-seated philosophical bias. They failed to study the American military's potential deeply enough to fathom the speed of their latent technological and industrial capacity to adapt and create specialized weapons. Japanese planners misapprehended the core economic difference between the two nations. They were accustomed to a war of material shortages and slow, painstaking development, akin to their German allies. The thought that the immense U.S. industrial base could rapidly translate a novel scientific principle into a mass-produced, easily deployed weapon, a true industrial shortcut, was an unknown unknown they simply failed to calculate. Their failure to predict the enemy's logistical and manufacturing momentum was a critical strategic misstep that preceded the HVAR's deployment. The strategic failure of the Japanese defense, therefore, began not with a massive air battle, but with the intellectual rigidity that precluded the possibility of the multi-role fighter. They had designed a defense against the past, expecting World War I-era tactical constraints, and were about to be blindsided by a weapons system that was fundamentally modern. This technological surprise would prove far more devastating than any loss of aircraft, as it immediately rendered thousands of fixed defensive positions strategically obsolete, proving the ultimate strategic power of American ingenuity. The coming shock was the ultimate proof that the ingenuity of American technology was a greater force multiplier than the Japanese reliance on predictable strategy. The IJN was prepared for the bomber. It was entirely unprepared for the high-speed fighter that instantly became a bomb. This single weapon would force the Japanese High Command to fight a technologically modern war with an antiquated strategic doctrine, dooming their final defenses. By 1943, the U.S. Navy faced a devastating attrition crisis in its reliance on the SBD Dauntless dive bomber. The Dauntless, a symbol of naval air prowess since the Battle of Midway, was lauded for its exceptional accuracy, a feat achieved by entering a slow, controlled dive at a nearly vertical 70 to 80-degree angle, allowing the pilot maximum visibility and time to precisely aim the bomb before release. This capability was invaluable against moving targets like ships and required a highly specialized aircraft and highly experienced pilots. However, this specialization came at a devastating strategic cost: extreme vulnerability. The slow speed of the Dauntless during the bomb run, and especially during the precarious recovery phase after the dive, turned it into an easy and obvious target for Japanese fighter intercepts, particularly the numerous and maneuverable Zeros. Furthermore, the slow dive exposed the bomber to sustained, accurate fire from heavy anti-aircraft artillery, AAA, protecting Japanese strongholds. As the Japanese deployed more sophisticated radar and concentrated more firepower around their island bastions, the attrition rate for the unescorted Dauntless and TBF Avenger began to climb to strategically unsustainable levels. The Navy simply could not afford to lose experienced crews and aircraft at such a pace. The strategic imperative facing the Bureau of Ordnance was clear. They needed a ground attack weapon that could deliver the necessary destructive power of a small bomb while ensuring the high speed and survivability of its top-tier fighter aircraft, the F-6F Hellcat and F-4U Corsair. Simply strapping the standard 500-pound general-purpose bombs onto the wings of a fighter, which was the conventional solution, proved inadequate. The bombs severely compromised the fighter's aerodynamics, speed, and range, turning the Hellcat into a sluggish, predictable, and vulnerable target. The accuracy from a high-speed, shallow pass was also insufficient for hitting hardened targets like coastal artillery bunkers, frustrating pilots and wasting ordnance. The solution could not be an incremental improvement in bomb technology or better anti-aircraft suppression. It demanded a revolutionary conceptual leap, a shift away from the free-falling, gravity-dependent bomb and toward a self-propelled, high-velocity projectile. This new weapon would have to be easily carried by the fastest, most survivable airframe on the carrier deck, and it needed to deliver the high explosive yield of a small bomb with the flat, controllable trajectory and minimal drag of a projectile. It had to allow the pilot to aim and fire from a high-speed pass, minimizing the time spent directly over the target. This paradox, the need for bomber accuracy combined with fighter speed, was the central technological challenge of the Pacific War in 1943. The answer, conceived and rapidly brought to production by the civilian scientists of the California Institute of Technology, Caltech, was the HVAR, nicknamed Holy Moses. This elegant technological solution was about to make the entire class of dedicated dive bombers strategically obsolete, delivering a shock to the Japanese defense that reverberated across the Pacific. The origins of the solution that would become known to American aircrews as Holy Moses lay not within the rigid military procurement bureaucracy, but in the rapid, innovative research conducted by the engineers and scientists at the California Institute of Technology, Caltech. These civilian ordnance specialists, working in collaboration with the U.S. Navy Bureau of Ordnance, had already established expertise in solid-fuel rocketry with the development of smaller 3.5-inch and 5-inch anti-aircraft rockets, proving the foundational concept of a stable, powerful motor for ship defense. The demand now was for a reliable offensive weapon that could be launched from an aircraft against hardened targets. The predecessor to the HVAR was the 5-inch forward-firing aircraft rocket, FFAR. While the FFAR had a respectable 5-inch diameter warhead, its rocket motor was underpowered, resulting in insufficient velocity and poor accuracy from the flatter trajectory required for effective air-to-ground use. The Navy required a rocket that was faster and delivered a flatter trajectory to eliminate the need for the dangerous, steep dive of the SBD Dauntless. This critical need for improved accuracy spurred the rapid and successful development of the successor. The result was the High-Velocity Aircraft Rocket, HVAR. It was a formidable piece of ordnance, consistently 5 inches, 127 mm in diameter for both its warhead and its dramatically larger rocket motor, and weighed approximately 140 pounds, 63 kg. The increase in motor size was the crucial step, boosting the propellant capacity from 8.5 pounds in the FFAR to a formidable 23.9 pounds, 10.8 kg, of ballistite. This massive increase in propellant gave the HVAR a superior specific impulse compared to similar British, German, or Soviet rockets. The HVAR was more than just a large shell. It was a carefully engineered kinetic system. Its solid-fuel rocket motor burned intensely for a brief period, approximately 0.9 to 1.2 seconds, accelerating the projectile to speeds over 1,500 feet per second, 950 mph or 1530 km/h. The key to the HVAR's strategic value was its massive kinetic punch and high stability. Fired from a fast-moving fighter, the HVAR effectively became a low-drag, self-propelled shell that could be aimed precisely at a target from a shallow dive or even level flight. It carried a significant 45-pound payload, including 7.6 pounds, 3.4 kg, of high-explosive TNT, or the even more powerful composition B, giving it the destructive power equivalent to a standard 5-inch naval shell. The high velocity achieved by the HVAR was the critical variable, providing the flatter trajectory and the momentum needed to penetrate up to 4 feet of reinforced concrete. The integration of the HVAR into the U.S. Navy's existing fighter fleet, primarily the F-6F Hellcat and the F-4U Corsair, was not merely a weapon upgrade. It was a doctrinal revolution that instantly created a true multi-role fighter. The Hellcat, already the dominant air-to-air platform in the Pacific, suddenly acquired a striking capability that the Japanese had never factored into their defensive planning. This technological synergy created a tactical problem for the IJN that had no easy solution. The deployment method of the HVAR reflected the American genius for robust, easily manufactured field equipment. The HVAR was mounted beneath the fighter's wings using simple, easily installed stub launchers, little more than short, rugged rails. This design allowed the fighter to carry up to 6, 8, or even 10 rockets with minimal aerodynamic drag compared to a conventional bomb. This was a crucial distinction. The fighter retained its essential high speed and maneuverability. For the F-4U Corsair, often the primary HVAR platform in the Marine Corps, this meant it could carry a devastating ground attack package while retaining its 400+ mph speed and formidable armament of .50 caliber machine guns. The tactical advantage was overwhelming and instantaneous. The fighter could approach the target at its maximum speed, minimizing its exposure time in the enemy's air defense envelope. Instead of the slow, vulnerable dive and recovery of the Dauntless, the pilot could align the target in the sight, fire the HVARs in a flat trajectory or shallow dive, and immediately pull away. The combination of the fighter's high speed and the rocket's supersonic velocity, up to 1,000 mph, meant the entire engagement was over in seconds, making the launch aircraft a nearly impossible target for Japanese light anti-aircraft batteries. The pilot gained full control over the engagement. HVARs could be fired individually, in pairs, or in a rapid-fire salvo, allowing for attacks on multiple targets or the concentration of fire on a single hardened objective. This capability fundamentally reversed the risk profile of ground attack. The fighter retained its survivability while delivering the destructive punch of a naval shell. This union of speed and high explosive yield gave the U.S. Navy and Marine Corps a decisive, cost-effective tool for suppressing Japanese coastal defenses, destroying supply dumps, and neutralizing anti-aircraft positions, missions that were simply too costly to assign to the dwindling supply of slower, dedicated bombers. The first major, widespread operational deployment of the HVAR occurred during the Marshall Islands Campaign in late 1943 and early 1944. This campaign, which saw the capture of vital Japanese forward bases like Kwajalein and Eniwetok, required the neutralization of heavy Japanese coastal artillery and reinforced defensive positions, targets that typically demanded sustained naval bombardment and high-risk dive bombing. This deployment marked the debut of the Holy Moses and the beginning of a new paranoia among the Japanese defenders. When Japanese observers initially spotted the fast-moving formations of Hellcats and Corsairs approaching their positions at low altitude, they correctly identified them as the U.S. Navy's primary fighter force. Based on their predictable doctrine, they anticipated a high-speed strafing run from the .50 caliber machine guns and prepared their light anti-aircraft weapons and infantry machine guns for a quick, low-level defensive burst. Their primary focus remained on tracking the slower bomber formations, which carried the bulk of the expected payload. The shock was immediate, visceral, and strategically devastating. Instead of the familiar rattle of machine gun fire, the defenders were met with the high-pitched, screaming roar of solid-fuel rockets, followed by the shattering, concussive explosions of 24-pound high-explosive warheads striking the ground with the force of naval shells. Coastal artillery bunkers, which had repeatedly shrugged off strafing runs and survived nearby high-altitude bomb drops, were cracked open, neutralized, and destroyed by the precise, flat trajectory and destructive kinetic energy of the HVAR. The rockets often achieved penetration and explosion within the concrete structure itself. The sheer noise, the terrifying acoustic signature, and the concussive force of the rocket barrage were psychologically crushing. The initial Japanese field reports were marked by confusion, alarm, and a profound failure to identify the new threat. Commanders struggled to classify the attacking aircraft. Was it a new, fast bomber, a specialized version of the Dauntless? The reports noted that the attacking aircraft were too fast for their Zero interceptors to engage effectively at low altitude, and too resilient for their light anti-aircraft fire to down, proving their doctrine of air defense had been fundamentally compromised. The HVAR had successfully introduced a massive new variable into the Japanese defensive calculus, proving that the American fighter was no longer confined to the air-to-air role. This forced the IJN to conclude, in paralyzing confusion, that the Americans had deployed a completely new, devastating class of close air support weapon, for which they had no counter-tactic and no doctrine, signaling the beginning of their strategic collapse in the Marshalls. The Imperial Japanese Army and Navy High Commands were completely blindsided by the high-velocity aircraft rocket. Their analytical failure was not due to a lack of intelligence-gathering effort, but a fundamental failure of strategic imagination rooted in their own industrial limitations and a stubborn underestimation of American technological adaptability. Japanese intelligence models were still tragically reliant on the technological landscape of the late 1930s, rigidly separating aircraft into specialized roles: fighters, dive bombers, and torpedo planes. Their intelligence reports on new American aircraft focused almost entirely on airframe performance, speed, climb rate, maneuverability, and defensive armament, while overlooking the crucial, smaller details of ordnance and payload integration. The concept of a simple, mass-produced rocket that could be mounted on a fighter to bridge the gap between strafing and bombing was entirely absent from their strategic forecasts. They calculated the Allied threat based on predictable aircraft type, not weapon system integration. This analytical rigidity was compounded by a profound misreading of the American industrial educational complex. The Japanese believed that any significant technological leap, especially one involving rocketry, which the Germans pursued as a complex wonder weapon, would be equally complex for the U.S., requiring months of research and large-scale, detectable industrial retooling. They failed to understand the breadth and rapid adaptation capability of the American educational and scientific infrastructure, particularly institutions like Caltech, which specialized in rapid, low-cost engineering solutions. The HVAR, however, was a deceptively simple piece of engineering built on existing, mature solid-fuel rocket technology. It was a rapid, low-cost solution that was rapidly integrated into existing fighter airframes and logistics chains. It was a massive strategic shortcut that produced a devastating effect. General Hatazo Adachi, commanding the 18th Army, and other Japanese commanders were forced to conclude that they were facing an entirely new weapon system for which they had no defense, and for which their air forces had no counter-tactic. The HVAR effectively negated the Japanese strategy of sheltering fixed assets from fighter sweeps, forcing them to spread their already scarce anti-aircraft and fighter assets thin, defending against an unpredictable dual-role enemy. The Japanese intelligence community's gross underestimation of the Allied capacity for innovation and resource mobilization proved a decisive factor in their defeat. They were fighting a dynamic enemy with a static intelligence model, ensuring that one of the most effective and survivable ground attack weapons of the Pacific War was deployed entirely under the veil of strategic surprise. The seamless integration of the HVAR with the U.S. Navy and Marine Corps premier fighter platforms, the F-6F Hellcat and the F-4U Corsair, was the moment the strategic balance in the Pacific fundamentally flipped. These aircraft, already dominant in the air-to-air role, suddenly possessed the devastating capability of a light bomber, creating a true multi-role fighter that the Japanese defense was entirely unprepared to classify or counter. The F-4U Corsair, in particular, a heavy, rugged aircraft renowned for its powerful R-2800 double WASP engine and high speed, 400-plus mph, found its true operational destiny as the Navy's premier land-based fighter and fighter bomber for the Marines. Armed with the HVAR, the Corsair became an overwhelming ground attack platform, capable of carrying up to 8 rockets, 4 under each wing, in addition to its formidable 6.50 caliber machine guns. This massive, precise payload gave the Marine Corps the on-call, destructive firepower they needed to support their brutal island assaults. The U.S. fighter pilots quickly adapted their tactics, focusing on the speed and low-altitude survivability provided by the HVAR. They would fly in low and fast, using the rockets to suppress or destroy hardened anti-aircraft positions before making a secondary, more conventional strafing run with their machine guns. This rocket-first tactic proved immensely effective. The HVAR's concussive blast and 4-foot concrete penetration often forced AA crews to abandon their positions, allowing the subsequent machine gun attack to proceed unmolested. The critical difference was survivability. The Corsair's rugged airframe, designed to withstand the stress of high-speed carrier landings, proved exceptionally resilient to the light anti-aircraft fire prevalent at low altitudes during ground attack runs. The Japanese defenders were forced to expend massive amounts of light ammunition to inflict minimal damage on a fighter that was carrying the payload of a bomber. The F-4U Corsair, armed with the HVAR, effectively merged the devastating punch of the bomber with the high-speed maneuverability of the fighter, permanently altering the balance of power in the ground war across the Pacific Islands. The Japanese generals were now faced with a nightmare scenario. Their highest priority targets, the fighters, were also their most devastating ground attack assets. This forced them to divert precious and scarce anti-aircraft resources and interceptors from defending their main fleet to defending static ground installations, a strategic dissipation of force that accelerated their defeat. The high-velocity aircraft rocket quickly earned its famous nickname, Holy Moses, among American aircrews and ground personnel, a moniker that captured the weapon's sudden, devastating impact. But for the Japanese defenders, the rocket became a source of acute and profound psychological trauma and battlefield terror, a fear that transcended the physical destruction it inflicted. The sound itself became a weapon. The HVAR's solid-fuel motor produced a distinctive, screaming, high-pitched roar during its brief 0.9 to 1.2-second burn, a sound that was immediately recognizable and distinct from the familiar whistle of a falling bomb or the drone of an aircraft engine. This terrifying acoustic signature announced the immediate arrival of devastating, accurate firepower with minimal warning. For the Japanese ground troops, the sound of the Holy Moses meant instant, localized annihilation, delivered by an enemy aircraft that was moving too fast to track and too nimble to hit. The sound alone was often enough to break the morale of anti-aircraft crews and infantry positions before the explosions even hit. Furthermore, the rocket's accuracy and flat trajectory destroyed the Japanese soldiers' illusion of safety provided by traditional fortifications. Japanese commanders had relied heavily on dug-in positions, reinforced concrete bunkers, and revetments designed to survive conventional bombardment. The HVAR, however, could be aimed directly into the entrance of a cave, the aperture of a bunker, or the side of a pillbox with pinpoint precision. The sheer kinetic energy of the 140-pound projectile, combined with the 24-pound HE warhead, was often sufficient to breach the hardened defense, destroying the occupants in a single, concussive blast, an effectiveness equivalent to a small naval shell. The HVAR could even penetrate 4 feet of reinforced concrete. This combination of physical destruction and psychological pressure, the scream and the accuracy, created a new paradigm of fear. The Japanese soldier was trained to fight bravely against a visible, measurable threat, often relying on the honor of a final banzai charge. The HVAR was perceived as an invisible, silent approaching weapon that provided no warning until the final, terrifying scream, convincing the defenders that the Americans possessed a weapon of overwhelming, total technological dominance. The rocket attacks were profoundly demoralizing, destroying the Japanese sense of tactical safety and leaving them convinced that no fortification could withstand the technological onslaught. The HVAR was a logistical masterpiece, perfectly suited to the rapid, island-hopping advance of the U.S. forces across the vast distances of the Pacific. Its simplicity and ease of deployment allowed it to become a readily available asset, a feat of industrial and logistical planning that completely bypassed the complexities of conventional ordnance. The Japanese, hampered by their long, vulnerable supply lines and inability to mass-produce complex weapons, could never have conceived of such a flexible, abundant system. The rocket's design was inherently simple, a steel tube containing a large solid propellant charge, 23.9 pounds of ballistite, a standard HE warhead, and simple fixed fins. This simplicity meant that the HVAR could be mass-produced rapidly by diverse manufacturing facilities across the United States. Its components were standardized, allowing for efficient shipping and minimal maintenance requirements in the field. Crucially, its robust solid fuel composition and simple fusing meant it could be handled and transported much more easily than conventional bombs, which required complex fusing and arming in the field, eliminating a logistical bottleneck. Crucially, the rocket's launch system was also simple and highly adaptable. The stub launchers were little more than short, rugged rails that could be bolted onto the wings of a Hellcat or Corsair in a matter of minutes. This field adaptability meant that air stations captured from the Japanese could be rapidly brought online, and the Navy and Marines could instantly integrate the HVAR capability into any fighter squadron, regardless of its primary role or experience with ground attack. The rocket effectively became a plug-and-play ground attack upgrade for the entire fighter fleet, a massive logistical force multiplier. This logistical flexibility meant that the HVAR could be delivered to the remotest air stations by cargo ships and immediately brought into action, quickly overwhelming the Japanese defenders with a sheer volume of high-explosive ordnance. The contrast with the Japanese munition supply, which was constantly hampered by material shortages and interdiction, was stark. The HVAR was a weapon of strategic abundance, allowing American pilots to use it not just for critical targets, but for routine suppression and harassment missions. The HVAR was not just a weapon of destruction, it was a weapon of logistical dominance, proving that American engineers had designed a system for warfare that the Japanese industrial base simply could not comprehend, let alone counter. The HVAR found its most critical application in neutralizing the heavily fortified coastal artillery batteries and fortress assault targets that formed the backbone of the Japanese defense perimeter. These were the targets that traditionally required massive, sustained naval gunfire support, putting irreplaceable battleships and cruisers at risk, or prolonged, costly air bombardment that resulted in heavy attrition of bomber crews. The HVAR offered a precise, high-speed alternative that reduced the risk to the valuable surface fleet. Japanese coastal artillery, often housed in reinforced concrete bunkers, was designed to repel amphibious assaults and inflict heavy casualties on the landing fleet. These bunkers were extremely difficult to destroy with conventional high-altitude bombing due to the thickness of the concrete, up to 4 feet, and a direct hit from slower naval shells was not always guaranteed. The HVAR, however, provided the perfect combination of accuracy, velocity, and explosive power. Fighter pilots, utilizing the HVAR's flat trajectory, could aim the rockets directly at the firing apertures or the exposed tops of the bunkers in a shallow dive, achieving a direct hit that the slower, more vulnerable Dauntless often struggled to attain. Furthermore, during the brutal assaults on islands like Peleliu and Okinawa, the HVAR became the primary tool for suppressing and destroying Japanese pillboxes, communication centers, and hidden gun emplacements that were holding up the Marine advance. Rocket-equipped Corsairs would fly rapid, low-altitude missions directly ahead of the infantry, prepping the enemy positions with precise HVAR barrages before the infantry assault. The ability of the rocket to destroy these hardened point targets, and the speed with which the fighter delivered the payload, provided the Marines with unprecedented on-call air support, an asset the Japanese could never match. The HVAR's ability to penetrate up to 4 feet of concrete made it an essential weapon for reducing these hardened positions. The Japanese defense strategy relied heavily on the durability of these fixed assets. The HVAR campaign effectively neutralized the Japanese advantage of prepared, hardened defenses, ensuring that the final battles were won by overwhelming, targeted firepower delivered by highly survivable aircraft. The HVAR was not just a naval weapon, it was the leading edge of the infantry assault, providing the critical shock necessary to dislodge deeply entrenched defenders. The Japanese military, recognizing the devastating effectiveness of the HVAR, attempted to develop counter-strategies, but their efforts were largely futile, hampered by their own technological limitations, industrial scarcity, and rigid bureaucracy. They were attempting to fight a modern, adaptive enemy with a static, pre-industrial war machine. The most obvious counter-strategy was to increase the number and caliber of light anti-aircraft weapons, machine guns, rapid-fire cannons, and light flak guns, around vulnerable fixed assets. However, their industrial base, already under immense pressure and constantly struggling with material shortages, could not match the scale of American production. Any anti-aircraft weapons that reached the forward bases were quickly overwhelmed by the sheer volume and speed of American fighter strikes. Japanese logistics, hampered by U.S. submarine warfare and a lack of manpower, struggled to deliver even basic supplies, let alone specialized AA ordnance. A more tactical countermeasure involved dispersing assets and utilizing camouflage to hide vulnerable targets from the fast-approaching HVAR attacks. Japanese commanders moved supplies and communication centers into jungle cover and deep caves, hoping to minimize the damage from the highly accurate rocket. Yet this dispersion and reliance on cover severely hampered their own communication and logistical efficiency, slowing down their ability to respond to the Marine landings and reducing their overall combat effectiveness. This tactical retreat itself accelerated their strategic defeat. Ultimately, the Japanese were trapped by their original strategic miscalculation and industrial reality. The HVAR was an inexpensive, mass-produced solution that negated their entire defensive model. Their only true countermeasure would have been to regain air superiority, but by 1944, the superior performance and training of the F-6F Hellcat and F-4U Corsair, combined with the overwhelming numerical advantage, had already made that goal impossible. The Japanese were forced to fight a technological battle with a pre-industrial strategy, ensuring their ultimate defeat. They attempted to develop their own wonder weapons late in the war, such as jet fighters like the Kikka, but these were too little too late and never eclipsed Allied technology. The HVAR permanently changed the definition of the naval fighter, establishing a new class of multi-role aircraft that was equally adept at air-to-air combat and ground attack. This conceptual shift had profound and lasting consequences for naval air doctrine, extending far beyond the Pacific War and defining the future of military aviation. The success of the rocket-equipped Hellcat and Corsair demonstrated conclusively that a dedicated bomber was no longer necessary for most tactical ground attack missions. The superior speed, survivability, and maneuverability of the fighter, when combined with the accurate, high-yield payload of the HVAR, rendered the slow, vulnerable dive bomber obsolete. The venerable SBD Dauntless, a hero of Midway, was rapidly phased out of frontline service in favor of the rocket-equipped fighters. This doctrinal shift led directly to the post-war development of true fighter bombers, such as the Thunderjet and the F-105 Thunderchuff, aircraft designed from inception to handle both the rigors of high-speed aerial combat and the heavy lift and stresses of ground attack. The HVAR proved the strategic value of versatility and survivability in air combat missions, showing that a fighter that could carry a massive ordnance load without significantly compromising its flight envelope was the future of naval air power. The American genius was not just in inventing the rocket, but in immediately recognizing and exploiting its potential to merge two previously distinct military roles into a single, devastating platform. The HVAR became the template for subsequent air-to-surface rockets and missile systems, proving that a low-drag, high-velocity kinetic weapon was the superior delivery method for fighter aircraft. The Japanese generals' failure to anticipate this conceptual shift meant they were fighting a naval war based on 1930s technology, while the Americans were already perfecting the doctrine of the modern multi-role fighter. The Japanese generals, already reeling from the massive output of American aircraft and ships, were equally unprepared for the speed and scale with which the United States could produce the HVAR. The rocket quickly became one of the most mass-produced pieces of ordnance of the war, a logistical marvel that kept pace with the explosive growth of the U.S. Navy's fighter fleet. The industrial capability required to produce over 1 million rockets was simply incomprehensible to the Japanese. The rocket's simple design, centered on a steel tube containing a large solid propellant charge, ballistite, meant that its manufacturing process could be distributed across numerous American industrial centers. Existing munitions and steel fabrication plants were rapidly retooled to stamp out the HVAR components, ensuring a continuous, reliable flow of the weapon to the Pacific. By the end of 1945, the United States had produced over 1 million HVARs, a staggering figure that confirmed the overwhelming nature of the American industrial commitment. This torrent of high-explosive power ensured that every fighter squadron in the Pacific could be consistently equipped with a full rocket loadout, eliminating the need for strict rationing or selective deployment. The HVAR was a weapon of strategic abundance, allowing American pilots to use it not just for critical targets, but for routine suppression and harassment missions. The vast quantities produced meant that pilots could fire their rockets in pairs or rapid-fire salvos to ensure a hit, a luxury unavailable to the resource-strapped Japanese forces. The Japanese industrial base, by comparison, was already struggling with crippling material shortages and constant disruption from Allied strategic bombing. Their inability to mass-produce even their primary fighter aircraft, producing only 85,611 planes to America's 295,959, made the American capacity to produce over 1 million HVARs utterly unimaginable. The HVAR was a direct product of the American industrial might that the Japanese generals had so disastrously underestimated, providing a decisive material advantage that no amount of fighting spirit could overcome. The psychological impact of the HVAR is vividly documented in the post-war interrogations of Japanese prisoners and in the accounts of captured Japanese documents. The rocket became a symbol of American technological ruthlessness and overwhelming power, permanently breaking the morale of entrenched Japanese defenders. Japanese prisoners consistently described the scream of the rocket as the most terrifying sound of the Pacific War, often more demoralizing than the whistle of a heavy artillery shell or the drone of a bomber. They noted the HVAR's precision and the futility of their hardened defenses, concluding that the American forces possessed a weapon capable of killing them even inside their most secure bunkers. The Japanese soldier was trained to die fighting, but they were not trained to be hunted down by an invisible, screaming weapon delivered by an aircraft they could not catch. In one noted post-war interrogation, a high-ranking Japanese staff officer, commenting on the defense of Iwo Jima, stated that the constant, precise HVAR attacks on the cave entrances and pillboxes were instrumental in breaking the defenders' will and reducing their command effectiveness. The psychological pressure of knowing that fast-moving fighters could deliver the explosive power of a cruiser's shell with pinpoint accuracy destroyed the Japanese sense of tactical safety and martial honor. The sustained, massive-scale use of the HVAR fundamentally changed the Japanese soldiers' perception of the war. They faced an enemy who could not only overwhelm them numerically, but could also introduce new, devastating weapons at a moment's notice. The HVAR campaign was perceived not just as a conventional use of force, but as a weapon of technological persecution, destroying the Japanese sense of tactical safety and military predictability. The relentless, screaming barrage convinced the defenders that their cause was hopeless. The final, devastating proof of the HVAR's strategic importance came during the bloody campaigns for Iwo Jima and Okinawa in 1945. These islands, the final bastions of Japanese defense, were transformed into vast, integrated fortresses designed to inflict maximum casualties on the invading forces. The HVAR was the key to unlocking these defenses. At Iwo Jima, Marine Corps Corsairs, operating from newly constructed forward airfields, flew thousands of sorties, using the HVAR to systematically destroy Japanese cave entrances, concealed artillery, and machine gun nests. The rockets provided the close, on-call fire support that the Marines desperately needed, often striking within a few hundred yards of the advancing infantry. The flat trajectory and high explosive punch of the HVAR were perfectly suited to the volcanic, bunker-ridden terrain of the island, achieving precise hits on hardened targets. The scale of the rocket campaign was unprecedented. During the Okinawa campaign, U.S. Navy and Marine fighters expended over 40,000 HVARs, a sheer volume of high-explosive ordnance that demonstrated the industrial scale of the ground attack. The sustained, accurate barrage of rockets crippled the Japanese defense, destroying supply depots, command centers, and AA positions, accelerating the final, inevitable collapse. The HVAR campaign effectively neutralized the Japanese advantage of prepared, hardened defenses, ensuring that the final battles were won by overwhelming, targeted firepower. The strategic failure of the Japanese generals was laid bare on these final islands. They had prepared for months to inflict massive casualties, but they had not prepared for the speed, accuracy, and volume with which the Americans could deliver the HVAR. The rocket turned their most secure subterranean positions into death traps, ensuring that their carefully prepared defenses were systematically dismantled from above, proving that the multi-role fighter was the ultimate key to final victory. The Japanese generals' failure to anticipate the HVAR was a failure to comprehend the American doctrine of continuous technological adaptation. The U.S. military machine was not static or predictable. It was a dynamic, decentralized organism that constantly sought and deployed rapid, cost-effective solutions to battlefield problems, a flexibility that the Japanese industrial and military structure simply could not match. The HVAR was born out of operational necessity, a simple, elegant solution to the problem of fighter vulnerability in the CAS role. Its development by civilian scientists at Caltech and its rapid integration by the Bureau of Ordnance bypassed the slow, rigid bureaucratic processes that often plagued military innovation. This ability to rapidly translate a scientific principle, solid fuel rocketry, into a mass-produced, effective battlefield technology was the true source of American dominance. The Japanese generals, steeped in a culture of rigid military hierarchy and slow-paced, centralized industrial planning, were entirely unprepared for this fluid, adaptive enemy. They believed the only significant technological leaps would be complex, expensive projects, similar to their own efforts or those of the Germans. They were fighting a war against a static set of industrial capabilities. The Americans were fighting a war against the idea of technological limitations. The HVAR was the ultimate demonstration of this dynamic ingenuity, proving that the American war effort was a continuously improving system designed for total dominance. The HVAR's strategic success in the Pacific marked the definitive end of the dedicated dive bomber era. The venerable SBD Dauntless, a hero of the early war, was rapidly retired from frontline service, and naval air doctrine was permanently shifted toward the fighter-bomber concept. The HVAR served as the catalyst for this monumental change. The lessons of the Holy Moses, the need for high-speed delivery of accurate, high-yield ordnance, were immediately integrated into the next generation of American jet aircraft. The principle of using high-speed, survivable platforms to deliver accurate, non-gravity-dependent explosive payloads became the foundation for Cold War-era close air support, defining the requirements for aircraft like the Thunderjet and the F-105 Thunderchief. The HVAR itself remained in service for decades, a testament to its simple, effective design. The Japanese generals, in their rigid adherence to a strategy based on static aircraft roles, suffered a catastrophic and complete strategic surprise. The small, screaming rocket not only defeated the Japanese defenses, but also redefined the future of air power. The HVAR was not just a weapon of World War II. It was a harbinger of the modern multi-role fighter, a simple, powerful testament to the triumph of adaptability over predictability. The post-war analysis conducted by surviving Japanese staff officers provided the final, damning confirmation of the HVAR's strategic impact. These captured documents and interrogations revealed a consistent pattern of confusion and paralysis within the High Command regarding the new weapon. Japanese commanders admitted that they had no effective tactical countermeasure to the rocket-equipped fighters. Their air superiority fighters, the Zero and the Shidenkai, were effective against unescorted bombers, but they were too slow and too thinly deployed to intercept the lightning-fast, low-flying HVAR strikes. Their ground-based air defenses were similarly optimized for high-altitude bombardment, leaving them critically vulnerable to the flat, high-speed rocket approach. The consensus among the analysts was that the HVAR represented a technological singularity that negated their entire defensive strategy. It was a low-cost, mass-produced solution that rendered their expensive, heavy fortifications largely obsolete. The final admission was one of profound strategic failure. They had underestimated the speed and simplicity of American innovation, and they had paid the price in absolute defeat. The HVAR was the technological weapon that merged the two spheres of combat, ensuring total American dominance from the air to the ground. The story of the high-velocity aircraft rocket is the ultimate case study in the triumph of simplicity and adaptability over rigid strategy and predictability. The Japanese generals, steeped in a martial tradition that valued specialized precision and expected predictable threats, were defeated by a weapon that was none of these things. The small, screaming rocket delivered a massive, disproportionate psychological and material shock to the Japanese defense. It took the most survivable airframe on the carrier deck, the Navy fighter, and gave it the high explosive punch and accuracy of a naval shell, forever blurring the lines between fighter and bomber. The HVAR taught the world a critical lesson in modern warfare. Strategic vulnerability is created by technological rigidity. The Japanese believed they knew the rules of the game. The Americans simply introduced a new piece that broke all the old ones. The scream of the Holy Moses was the sound of a new era of air power being born, signaling the final, inevitable collapse of the imperial defense perimeter. The Japanese generals' failure to anticipate the high-velocity aircraft rocket, HVAR, was made more complete by the stark contrast with their own attempts at developing similar ordnance. While the Germans had pursued rocketry as a complex, last-ditch wonder weapon, like the V-2, the Japanese struggled with even basic rocket artillery, often deploying less stable, inaccurate projectiles for coastal defense in futile attempts to counter the sheer volume of Allied naval fire. Their programs were plagued by material shortages, industrial limitations, and an inability to mass-produce reliable solid-fuel motors. Japanese engineers lacked the widespread, foundational industrial infrastructure and the chemical expertise necessary to develop a rocket motor of the HVAR's efficiency. The HVAR utilized ballistite propellant, which had a superior specific impulse compared to the formulas used by Japanese, German, or Soviet rockets. This critical difference in propellant efficiency directly translated into the HVAR's superior velocity, up to 1,500 feet per second, and its crucial flat trajectory, the very elements that made it a precise, fast ground attack weapon. The Japanese had no equivalent capability. The disparity was not merely technical, it was systemic. Where American civilian scientists at Caltech could rapidly transition from laboratory concept to mass production, the Japanese system was hampered by bureaucratic rigidity, inter-service rivalry between the IJN and IJA, and the crippling shortage of essential materials like quality steel and aluminum. Any complex weapon system, such as their late-war jet projects like the Kika, suffered from engine problems, material compromises, and production delays, often resulting in projects being too little, too late. The Japanese High Command's focus remained disproportionately on air superiority fighters and large naval gunnery, viewing ground attack rocketry as a secondary, low-priority field suitable only for terror or saturation fire, not for precision engineering. They failed to recognize the HVAR as a piece of precision ordnance capable of artillery-level penetration, viewing it instead as glorified fireworks. This fundamental misjudgment ensured that no serious research was invested into defensive countermeasures against such a simple, high-velocity projectile, leaving their defenses fatally exposed. The American ability to achieve speed and precision with the HVAR starkly highlighted the Japanese failure to foster a dynamic, adaptive industrial military complex. They were fighting a war of attrition, where the material deficiencies were amplified by a technological gap they were utterly incapable of closing. The HVAR was proof that America's economic and intellectual engine was operating on an entirely different plane of complexity and output. The shock of the HVAR, therefore, was a direct consequence of the Japanese belief that their technical development was on par with or superior to that of the Allies. They had fundamentally underestimated the speed with which the U.S. could leverage its extensive educational infrastructure and manufacturing depth to create a rapid, decisive solution to a complex military problem. This oversight proved fatal to their static defense strategies. To fully understand the destructive shock delivered by the HVAR, one must look beyond its simple appearance and analyze the kinetic and explosive physics that made it so effective against hardened Japanese positions. The rocket was a near-perfect synthesis of velocity and payload, capable of inflicting damage equivalent to a much heavier, slower weapon. The HVAR weighed approximately 140 pounds, 63 kg, and was propelled by 23.9 pounds of ballistic propellant, which burned for just over 1 second to accelerate the projectile to speeds up to 1,530 km/h, 950 mph. This high velocity was the key component in its lethality, as the kinetic energy alone allowed the rocket to punch through defenses that would stop a standard, slower bomb. The high delta-V achieved by the motor was an intentional design decision, ensuring the necessary flat trajectory and terminal velocity. The warhead, a formidable 5-inch caliber, contained a payload of approximately 7.6 pounds of high-explosive HE TNT, or often the even more powerful composition B, and was fitted with both nose and base fuses. This explosive yield was equivalent to a standard 5-inch naval shell or a 50-pound general-purpose bomb, but the delivery mechanism was exponentially faster and more accurate than a conventional drop. The combination of the sheer kinetic energy from the impact and the subsequent HE blast was devastating against concrete fortifications. The Japanese relied heavily on their reinforced concrete bunkers, often built with walls 3 to 4 feet thick, believing these to be impervious to anything less than a direct hit from heavy naval shells. The HVAR proved this belief wrong. The high-velocity rocket could penetrate up to 4 feet of reinforced concrete. This meant the rocket often detonated inside the structure itself, maximizing the concussive and fragmentation damage against the personnel within, an outcome far more decisive than an external explosion. Furthermore, post-war versions of the HVAR were developed with specialized warheads, including semi-armor-piercing, SAP heads, and even shaped charge heads for use against armor. While the standard HE round was the most common, the flexibility of the design proved its lasting strategic value. The HVAR effectively weaponized the principles of high-velocity kinetics, delivering a devastating, precise payload that turned the Japanese soldiers' ultimate refuge, the concrete bunker, into a strategically vulnerable target. This change in physical reality was the final, undeniable proof that the war was lost. The logistical infrastructure supporting the HVAR was as strategically devastating as the rocket itself, demonstrating the overwhelming American logistical might that Japanese planners had consistently failed to forecast. While Japanese forces struggled to move basic food and ammunition through choked, submarine-interdicted sea lanes, the U.S. Navy achieved a seamless, massive-scale distribution of this complex new ordnance. The key to this logistical dominance was the HVAR's simplicity and standardization. Because the rocket's components, the motor tube, fins, and warhead, were rugged and non-fragile, They could be mass-produced and shipped in staggering quantities without the need for delicate handling required by specialized fusing or precision guidance components. The components were often shipped separately and assembled at forward air bases near the combat zone, a highly efficient form of distributed manufacturing that minimized damage risks during transport across the vast Pacific. The production numbers alone are a testament to this logistical mastery. By the end of the war, the U.S. had produced over 1 million HVARs. This volume ensured that there was virtually no rationing. The weapon was one of strategic abundance, allowing fighter pilots to fire their rockets in pairs or salvos to maximize the chance of a hit, a luxury unavailable to the resource-starved Japanese forces. This capability also meant that replacement rockets were instantly available at forward bases, like those captured during the Marshall Islands campaign. The ease of integration into the fighter fleet was the final logistical triumph. The simple stub launchers were rugged, easily manufactured, and quickly bolted onto the aircraft wings, transforming the fighter's capability in hours, not weeks. The entire logistical chain, from the Caltech lab to the factory floor to the ship's hold to the forward airbase, was optimized for speed and simplicity. The Japanese, who lacked the massive U.S. naval logistics effort and manpower pool, could not fathom this level of efficiency and resource mobilization. The HVAR arrived not just as a weapon, but as an undeniable physical symbol of American industrial and logistical inevitability. The deployment of the HVAR induced a state of tactical paralysis within the Japanese High Command, forcing them to make a series of fatal, resource-wasting decisions that were doomed to failure. Their adherence to a static doctrine ensured they were always one step behind the adaptable American forces. The core dilemma created by the HVAR was the sudden imbalance of defense priorities. Japanese defenses were built around repelling the high altitude, slow-moving bomber formations, and achieving air-to-air parity with Zero fighters against Hellcats. The HVAR instantly merged these two threats, forcing the Japanese to defend their fixed-ground assets not from slow bombers, but from the very fast fighters they needed to counter in the air. This meant spreading their already scarce light anti-aircraft artillery, AAA, to defend widely dispersed bunkers, weakening the concentration of fire needed to deter actual bomber attacks. The Japanese responded by futile attempts at tactical adaptation. They tried to reposition their limited fighter interceptors to catch the HVAR-equipped Corsairs during their low-level attack runs, a difficult and often suicidal task due to the Corsair's speed and the pilot's quick egress. They attempted to create ambush zones with light machine guns, but these positions were often the first targets obliterated by the HVAR's accurate, high-explosive barrage, further degrading their low-altitude defenses. The final failure was the inability to develop an internal equivalent. Japanese engineers, lacking the necessary industrial depth and technical foundation in solid-fuel rocketry, could not rapidly replicate the HVAR's performance or mass-produce a counterweapon. They were forced to watch helplessly as their static defenses were systematically dismantled by a low-cost, high-volume projectile. The HVAR proved that the American ability to rapidly innovate and deploy technology had negated the Japanese strategic advantage of prepared, hardened defenses, ensuring that their limited resources were constantly committed to a losing battle. The paralysis of command was complete. They had no good tactical options left. The strategic impact of the HVAR is best understood by comparing its lethality and operational profile against the two primary weapons it effectively replaced in the close air support role: the free-falling general-purpose bomb and the aerial torpedo. This comparison shows that the HVAR was not merely an alternative, but a superior, more survivable tactical solution. The HVAR offered a decisive improvement in accuracy and survivability over the conventional 500-pound general-purpose bomb, especially against point targets. While a fighter carrying a bomb had to execute a demanding dive maneuver and was susceptible to wind and drag, the HVAR, being self-propelled, offered a flatter, more stable trajectory that was less affected by external factors. The rocket's high velocity meant the pilot spent mere seconds over the target, drastically reducing vulnerability to light anti-aircraft fire compared to the slow recovery of a conventional bombing run. The destructive force was comparable to a 5-inch naval shell, ensuring the impact was sufficient for hardened targets. Against the aerial torpedo, the HVAR offered a high-speed replacement for anti-shipping and coastal interdiction. While the torpedo was devastating, it required a slow, low-altitude run to drop, making the aircraft highly vulnerable to AA fire and difficult to deploy against small, fast transport ships or coastal targets. The HVAR, with its high velocity and powerful HE warhead, could effectively sink smaller transports, knock out pillboxes on the coastline, and neutralize coastal defense guns in a high-speed pass, making the fighter far more versatile and survivable than a dedicated torpedo bomber. Furthermore, the logistical advantage was immense. The HVAR was a simple projectile, easily mass-produced and integrated, while torpedoes were complex, precision-engineered weapons that were difficult to manufacture, transport, and maintain in the field. The HVAR was a cost-effective, multi-purpose solution that offered high lethality and low risk, proving that technological simplicity, when mass-produced, was the ultimate strategic force multiplier. The Japanese were defeated by a weapon that maximized destructive power, while simultaneously minimizing the exposure time of the valuable pilot and aircraft. The story of the high-velocity aircraft rocket is the ultimate case study in the triumph of simplicity and adaptability over rigid strategy and predictability. The Japanese generals, steeped in a martial tradition that valued specialized precision and expected predictable threats, were defeated by a weapon that was none of these things. The HVAR delivered a massive, disproportionate psychological and material shock to the Japanese defense. It took the most survivable airframe on the carrier deck, the Navy fighter, and gave it the high explosive punch and accuracy of a naval shell, forever blurring the lines between fighter and bomber. This shift redefined naval air power and rendered static defense obsolete. The HVAR taught the world a critical lesson in modern warfare. Strategic vulnerability is created by technological rigidity. The Japanese believed they knew the rules of the game. The Americans simply introduced a new piece that broke all the old ones. The scream of the Holy Moses was the sound of a new era of air power being born, signaling the final, inevitable collapse of the imperial defense perimeter. The final strategic failure of the Japanese generals was their inability to predict the American capacity to rapidly translate scientific principle into mass-produced, effective battlefield technology. They were defeated by a screaming, 5-inch rocket that proved industrial ingenuity and adaptability were the decisive factors in the Pacific War.